Yeah, good evening, guys. Can you hear me? Yeah, Mr. Audit, I greet you. How was our day? Hope you had a nice time. Today seems to be the second to the last day, and so far so good. We we've come pretty much far into the training, and hopefully we find a way to round things up today, so that tomorrow is just going to be. Yeah, mine was stress free also. Even though I was stressed initially in the morning, I had to relax my head and catch some sleep in the afternoon so that I can pull myself together. All right. So tomorrow I'm going to share a Zoom link tomorrow so we can it's just going to be a good time to catch up, right, with each other. Let's wait a little bit to see if this would sort of work. If it doesn't, see if it comes up from your end.
No. Right.
Came up from here.
Yeah.
Not
Yes.
from here though.
That's right.
All right, guys. Confirm you can hear me, please. Hopefully, we don't have any disruption again. All right. So yeah, I mean, just imagine 32 minutes is gone because my laptop was, disrupting the whole thing. Okay. Um,
Yes.
yeah, let's just quickly get started. I mean, there's nothing more to do. Time has gone already. So okay. So yesterday started with the load auditing, right, and also the sizing of the. We saw the sizing of the inverter. We saw that of the battery also. And then today we're just going to do sizing the solar panel up. So I gave us an assignment. How many of us did it? Did you do the assignment? How many did the assignment? How many did it? That's how we know you guys are graduating. If I didn't see if I didn't see what's it called? There's no way I would know. So this is kind of like what I ask us to do. Coming. Nobody did the assignment. Ah, I'm breaking my heart already. Alright. Confirm you can see my screen. I was too busy today, but I'll try it. All right. So this kind of like what I ask us to do, right? The load, the quantity, the light, right? Five of it, each power rating for each of the appliances, right? And then you And that's what gives you the total wattage. So I said yesterday that this value, which is 750 watts, is what you use to calculate the inverter size, not this one. All right, not this one. This is the one you're going to use. All right, and this value here is what you use to calculate the battery size, and as well, of course, the solar panel size that you're going to need also. All right. So this value here, all right, is what you use to calculate the battery size. This is what you use to calculate what the inverter size and all of that. So you can take a screenshot of this. And let me just screenshot it to the group chat. All right. So yeah, so you could use this to this kind of like what I expected us to do. All right. Okay. So let's just move on to, though I don't have yesterday's data again, so I'll be working with this data, all right? I'll be working with this data. So now the total wattage is 750, all right? How did that teach us to calculate the inverter size, right? First thing is you take this 750, all right, adjust for it, adjust for, I think the first thing was efficiency, right? Which is 25%. All right. So firstly, you multiply the 750 times 25% of it. All right. And then whatever that is, let me get my calculator. So 50 times 1.25. All right. So that's around 937 watts. All right. And then again, you multiply this value also by 20%, which is the power factor. All right. 1.2 multiplied by 1.2. So at the end, you're going to have 1.125 watts. All right. So, but you can't get, sorry, 1,000. I wanted to say 1,000. So you can't get 1,125 watts. You can only get around 1,500 VA or, sorry, VA or watt in the market. All right, that's what you're going to get. So buy 1,500 VA or 1,500 watt inverter in the market, and then you're good to go. All right. But then we also have to now calculate, confirm my YouTube is on. All right. Um, so the next thing you do after this um, is to get the battery size, right? So I said that this value here to get the battery size, all right? So this value here, you use it to get the battery size. So first thing you have to do for the battery size is so look at this already. Look at this too. Now the freezer is 300 watts. I'm just taking us back a little bit to just point out something. And this freezer, because of the fact that it's an inductive load, it can surge up to 3 to 4 times of this size. All right. So let's just assume it surges up to um, 4 times, which is 1,200. Right. Your inverter still cover it. Remember, your inverter also has 2 times surge rate, which means that it can actually handle up to 3,000 VA of load for split seconds, right? Which means with your inductive load, this inverter is still pretty much safe for it. All right. So yeah, I just pointed that out by the way. All right. So in order for you to calculate the battery that you're going to need, right? I did took us through two things that we have to put into consideration. Right. Let me just quickly load that up again. Let me share my full screen there. Okay. All right. Um, I'm sharing my screen now, so just uh okay. Sam said that I didn't do it. I mean, it's okay. It's okay. Just find time to do it. All right. So let me quickly go to the battery. Yeah. So we did go through this process. First thing is to get what the 1660, which is the data. Sorry about that. Which is the data you got from here, which is the total load that the client will be consuming daily. All right. And then what did you do again? We we divided that by 0.8. Now, this 0.8 is to add 20%. It's the same thing as multiplying by 1.2, right? So the idea is to increase the load by 20%. Why? Because the client also might want to increase the load without even telling you. And yet he'll be complaining that the battery is not serving him. He will not tell you that he has increased the load, right? So you want to also just be wise enough to sort of do that, all right? And that helps you, that gives you more cushion, right, for the battery, right? It gives you more cushion for the battery. So divide it by 0.8, all right? Divided by 0.8, and again you might want to use 1 day autonomy or 2 days autonomy or 3 days autonomy, depending on what that means is that let's make for the rainy days. All right, let's save for the rainy days. So it means that there are some days when the sun is not out, right? You want to ensure that you still have enough power on the battery to cover for those days. That's what autonomy means. Okay, so usually clients don't have that money to buy so much of power. I mean battery. So just use 1 day autonomy, which means that every blessed day, right? We assume that or we expect that the solar panel charges the battery fully. All right. So what happens when you get to rainy or cloudy days? It means that the battery will not be fully charged. So and of course the client has to be aware of that. All right, in your consideration. So the third thing is to first understand the type of battery you're using. Is it lithium-ion battery? Is it lead-acid battery? Is it gel battery? We said that if you're using lead-acid battery and lithium-ion, I mean, and gel batteries have depth of discharge of 50%. All right, which means that you can only get 50% of the rated capacity from them. So you have to be able to add 50% to whatever you're calculating. I hope that makes sense. All right. And after you get your the battery size that you will need, all right, you now have to what divide it by what the inverter voltage to give you what the current of that battery. So you have to take the current of the battery to the market to go and look for it. All right. And we said that you can't get, for instance, 307 in the market. All right. The only thing you could do is to maybe buy 200 AH, buy two of it and parallel it. So that's going to give you 400 AH, which even gives you more, power compared to 307 that you actually need. All right. So yeah, so that's for the battery, right? So today we're going to go to the panel, right? I'll have to share another file for that. Few minutes. So you also have to understand how to size your panel, right? The question is how much of panel, all right, will charge this battery, all right? How much of panel will charge this battery, all right? That's what we have to now look for, all right? So the first thing you have to understand about panels, for instance, is what's the stuff? All right. First thing we have to understand about panel is that there is a limited amount of power that can be made available to you during the day. All right. There is a limited amount of power that can be made available to you during the day. All right. And you have to work with that. All right. So now, what you have to do is to, for instance, in Nigeria here, I told us during the introductory class that we have up to 4 to 5 hours of sunlight every day under an average normal circumstances, right? So which means that within that 4 to 5 hours is what you have to charge the battery fully every day, all right? So once the sun goes down, right, your solar panel no longer charges. So you only have the space of about 4 to 5 hours to charge the solar panel, or I mean to charge the battery. Okay, so whatever amount of solar panel you're buying, you have to ensure that it's sufficient enough to charge the battery full within that time space that you have, that you have. All right. So let's say, for instance, I need this amount of energy, all right, which is the energy of my battery. Okay, so the solar panel I'm going to keep buying must be able to give me 3,688 watt hour per day. All right, it must be able to give me that per day. All right, so if it's able to give me that, but that means it's going to be able to deliver it to the battery, and it can successfully charge that battery fully. All right, I'll go again. My battery size is 3,688. All right. Actually, in the real sense, because of the fact that we're going to be getting two batteries here, right? This is going to be 488. So if you multiply it times 12, you're going to get another value. But let's just assume for now that my battery size is 3,688, right? I need to get an amount of panel that can give me this amount of energy every day. All right. I need to get the amount of panel that can give me this amount of energy every day. All right. So that if my panel can deliver this amount of energy to my battery daily, it means that my battery will always be fully charged every blessed day. All right. So I can then do this. Let me open up my notepad. Let me share it. Confirm my screen is visible. All right. It should be visible now. All right. So we have, I think, 3,000. What's our value again? 3,688, which is our battery. So our battery size, I mean, the battery power is 3,688 watts hour. All right. So we need a solar panel that can give us, all right, 3,688 watt hour per day. Right. Per day. So that's the size of solar panel that we need. Okay. So now let's just say this solar panel, this one that we have right here, can give me this energy per day. All right. Which means that if I connect this solar panel, all right, to this battery, it's going to fully charge this battery every day. All right. That is cool. All right. So one thing you have to note is that even if I'm able to get this size of solar panel, so let's say this panel is rated 3,700 watts. All right. This panel cannot deliver 3,700 watts. Why? Because, like I told us, no system is 100% efficient. All right. Panels are even worse. Okay. So most of the time, we assume that this panel can only deliver 65% of their capacity. All right. Which means that we can't get 3,700 from this panel. All right. So if you take the 65% of 3,700, 37 times 0.65. All right, that's 2,405 watts. All right, which means under every standard condition, this panel can only deliver to us 2,405 watts. All right, it can't deliver up to 3,700 because it doesn't have an 100% efficiency. All right, so that could be as a result of anything, right, from the temperature, the intensity of the sun, and so on. Okay, so now that I know that even if I go to buy 3,700 watts, 1,700 watts of this thing in the market, I can't get. That means I have to buy maybe two. All right, so that if I buy two, right, so let's say I buy two of these. All right, it means that according to the rating, this should be times two. All right, according to the rating, that means I'm buying times two. This should give me 0.04 uh, 47, right? 7,400. All right, watts. But ideally, we already know that we can only get 65% of it, right? So the 65% of it is going to be 4,000, right? 65% of this is only going to be what? 4,810 watts. All right. So that if I plug 4,000, all right, if I plug 4,000, slow down for me. If I plug 4,800 to it, all right, in fact, it's more than enough to charge it every day, all right. It's more than enough because this panel is telling me that it can deliver to me 4,810 watts per day. I hope you get the logic. Please let me know we're following. Are we following? Are you guys with me? I want to see our comments. Okay. All right. Cool. So now, having note all of these things, right? Very, very important. Very, very important. What you then have to do, all right, after I've explained all of these things, is to put into consideration all of these factors and work with them. All right. So let's go back to the slide I shared earlier. Where's the slide again? All right. So here is a formula here. Okay. Here's a formula here. Very simple, straightforward formula that you can use to calculate the size of the solar panel that you need. All right. It says that the PV module size, all right, is equals to total daily watt hour. All right, which means that the total amount of um, the energy that the client wants to consume daily. All right. Remember, in our case, is around 1,600 and something. All right. So that's what you're going to use here. All right. And then divided by average daily solar installation. Now, average daily solar installation is that 4.73 kilowatt per hour per square meter per day. All right. That's what I told you, that we have between 4 to 5 hours of sunlight daily. Okay. So if you actually want to streamline this properly, you could actually just use maybe 4, exactly 4.0 here. Or you can still go with 4.7 with this statistic. All right. So by the time you do that, right, let's use our own coming on. Let's use our own calculation. All right. Let me share my let me share my screen again. No, actually, all right. So please confirm you can see my screen now. Okay. In order for you to calculate your solar panel, you take this value, all right? I mean, not this value, right? Uh, okay. So to calculate your battery, right, you use this value, all right? So let's calculate the battery value that we're going to need to for this particular this thing again, right? That helps us reinforce this thing. So basically, you divide what 7,000, all right, 7,000 divided by firstly 0.8, okay, 0.8, and then you divide that value, all right. You also divide that value by of course, the days of autonomy is one, so don't even need to add that. All right, then depending on the type of battery you're using. All right, so if it's a lithium-ion battery, you also have to divide it by another 0.8. Okay, so firstly, let me just quickly do that. 7,000 divided by 0.8. That's 8,750. Okay. All right. So if you're using lead acid battery, you're going to use 0.5 um, to divide it again. All right. If you're using lithium ion battery, you're going to use 0.8. All right. Lithium ion battery gives you 80% efficiency. All right. So, but let's use 0.5 in this case. Let's use 0.5 in this case. Divided by 0.5. All right. That gives you 17,500. All right. So that's the size of battery. Okay, so now we need to find the panel that will help us, that will charge this battery for us daily. So the first thing that I said we're going to do is to take this value, all right, take this value, and so PV size, all right, PV size equals to total energy or battery energy, anyone, divided by 4.73, all right, as we have seen. So we take 17,500 divided by 4.73. All right. So we have 3,000, approximately 3,700. Okay. So approximately 3,700 watts. All right. So which means that the panel size we're going to buy, that we charge this battery fully under 3,007, I mean, under 4 to 5 hours is going to be 3,700. So for me to be safe, I will not use 4.73, all right, because I want to do a very good job for the client. I'm going to use 4, exactly 4, all right. So that's what I'm going to do. I'm going to use exactly 4. All right. All right, divided by 4. So I have 4,375. Okay. 4,375 watts. All right. So remember, what we did was to divide this by what? By 4. All right. So I got 4,000. So which means that the size of panel I'm going to buy is going to be what? 4,375. Remember, I then told us that panels are not 100% efficient. All right. Most of the time, we take 65%. All right. So you have to also divide this by 0.65. All right. So divided by 0.65. So this gives you 6,800 approximately. All right. So the size of panel I have to buy is going to be what? 6,800 watts of panel to charge this size of battery under 4 hours. All right, under 4 hours. So now, question is, if you go to the market now, are you going to see a single panel that is 6,800 watts? No, you can't. All right, you have to buy small panels, arrange them, and until they make up to 6,800 watts. That's all you have to do. All right. So uh, you have different size of panel in the market. So you have to first say to which size do I want to buy. To maximize space, you have to buy, for this amount of panel, you have to buy the highest panel that you can get, all right? Maybe around 610 watts in order for you to maximize space, right? Because you go and buy 100 watts. How many 100 watts? You are going to buy 68, all right? It doesn't make sense to, mount 68 panels on roof. Do you want to destroy the roof? You understand? So, and it's going to be stressful for you, safe. Okay, so, but I'm going to buy, for me, I'm going to buy 610 watts panel, all right? So I'm just going to divide this value by 610 to get the size that I need, divided by 610. So I have to buy 11, all right? So I have to buy 11 of these, all right? So I have to buy 11 of these. That means I'm buying 11 panels, all right? Please let me know if you get it up to this point. Do we get it up to this point? Please, guys, respond. Let me know before we move quickly. Okay. Okay. Cool then. Good. What about the rest? Okay, it's clear. All right. So yeah. So that's what is going to tell you the number of panels you are going to buy. All right. Now, um, to the vital part, which is how then are you going to connect 11 panels together? All right. How are you going to connect 11 panels together? All right. That is where you now have to bring back all of your components from the inverter, all right, especially the inverter and all of that. So remember, I told us about hybrid inverters and I told us about standalone inverters. So if your inverter is an hybrid inverter, you have to check what is the maximum voltage that this particular inverter can handle. All right. What is the maximum voltage that is inverter, maximum voltage and current that this inverter can handle? All right. So if what you see, you saw that, oh, the charge controller inside the inverter can handle up to 6,000. What's that value again? 6,800. All right. So if you see that the inverter, I mean, the charge controller inside the inverter can handle up to 6,800 watts, then you're good. All right, you're good. You can just, connect it, run your panels directly to it. And before you do that, you have to know the voltage of the inverter. I mean, the voltage, the maximum voltage that the charge controller inside the inverter can handle. So for most inverters, right, depending on the size, anyways, um, the maximum one would have up to 500 volts. All right. For a 610 panel, I mean 610 watt panel, the VOC, remember the VOC, that's open circuit voltage, is around 50 volts. So if you're connecting 11, that's 550 volts. So most inverter can handle only 450 to 500 volts. So if you're exceeding 500 volts, you can't connect up to 11. It means that you can only connect 10 to it. So yeah, so if you can't connect all the 11 on it, maybe you now remove one panel and tell the client that we can only connect to, or go ahead and buy a charge controller that can handle up to that amount of solar panel. All right. And how do you know the charge controller that can handle that amount of solar panel? Let's quickly do the calculation.
Sorry, that's
Mm. Okay, how the denominator. So yeah, I said that I for me, I'd always want to be on the safer side, so I just removed the 0.73 and used 4 instead of um, 4.73. But you can also use 4.73 if that's what you want. Okay, so it's not really a challenge. Does that make sense? The 4.73 is the number of hours that you have sunlight during the day. So you have to work with that value. Can't work with anything less than or higher than that. Okay. So now our panel size, all right, our panel size is 6,800 watts. All right. We have to look for the size of charge controller that can allow this 6,800. So the maximum charge controller that I've seen and worked with is 120 amps charge controller. All right. So keep that in mind. All right. You have from 20 amps. All right. You have from 20 amps, to you have 45 or 40. You also have 30 amps also. All right. You have 60 amps. You have 80 amps. You have 100 amps. You have also 120 amps. I think I've seen 250 somewhere, right? But I've not used it before. Okay. So now, how do I get the charge controller size? All right. Charge controller size. So the first thing is to take the size of the panel. All right. Um, Charge controller size equals to panel size over charging voltage. All right. Charging voltage. That is the simplest approach to do that. All right. So now we already know what our panel size is. Okay. But what about our charging voltage? Our charging voltage is going to be the charging voltage for your battery. In fact, let me write that. All right. So now I've said this before, right? That if you have a 12-volt battery, the charging voltage is going to be 14.8. If you have a 24-volt battery, the charging voltage is going to be 28.8. You might want to write that down. If you have a 48-volt battery, the charging voltage is going to be 57.6 volts. All right. For 12 volts, the charging voltage is what? 14.8. For 24-volt battery, the charging voltage is going to be 28.8. For a 48-volt battery, the charging voltage is 57.6. All right. So now, if I have a if I have my inverter size is if my inverter is 12 volts, right? It means that the battery I'm going to be using is going to be 12 volt also, right? It's usually your inverter voltage will always determine your battery voltage, all right? So if my inverter is, which most likely is going to be, because our inverter size is 1500 MVA, so it's most likely going to be a 12 volts, all right? So the charge controller size that I'm going to buy, all right, for that size of inverter is going to be 6800 divided by what? The 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 charging voltage of a 12-volt battery, all right, like I said earlier, is 14.8. All right. So I'll divide this by 14.8 for 24 volts. All right. For 24 volts is 28.8. All right. 28.8. For 48 volts is 57.6 volts. I hope you got it now. So this is going to give me the charge controller size of 460 amps. 460 amps. Because remember, we're dividing power by voltage. All right. So what you're going to be getting is amps. All right. So it means that I have to go and look for a charge controller size of around 460 amps. And remember, what if something happens on the panel and the power, all right, or the current of the panel increases a little bit, maybe to like 465? Does that mean my charge controller will damage because of a little spike? So it simply means that I have to also increase this by what? By 20% in case anything happens. All right, so that a little increase in current would not damage my 460 amps charge controller. I can't just go to the market and go and buy exactly 460 amps. It doesn't make sense. What if something happens and the current increases a little bit? Do I want to spoil my charge controller because of that? No. So I'll just bump it up a little bit by 20%. So times 1.20. So that gives me around 550 amps. So my final charge controller size is going to be what? 550 amps charge controller. All right. Remember, remember, I told you that you can't get more than 120 amps in the market. Maybe you can get around 250, but 120 amps is mostly what is you are going to get in the market. So how would you do it that you have is 120 amps? All right. The only thing you can do, I mean, that you can't use just one charge controller. All right. Obviously, you can't use um, a single charge controller. All right. Now, so you want to buy up to around 5 charge controllers. And how would you do that? You have to divide your panel 5 and put two in each panel. But that's waste of money. All right. That's waste of money. All right. So the best way to approach this, all right, the best way to approach this is to increase the voltage, all right, that is going to be going through the charge controller. I'll explain what that means. All right. I hope we have captured this one that I just did now. This works, all right, when you have a small system. All right. So I want to show us some of the manipulations that we do, all right, when we're trying to um, use our charge controller, or when we're trying to size up our charge controller. All right, please follow me carefully. This is the last stuff that we're going to consider. So let's just quickly round off. All right. So we still have 6,800 watt of panel. All right. So remember, it doesn't make sense to go and be buying five charge controller. Each charge controller is around 300K or 250,000. So buying five of that does not make sense when there's something else that you can do. There are points where you have to buy the five, right? But those are when you have more system, more PV than what we have now. All right. So for what we have now, 6,800, you don't have to buy five charge controllers. All right. So what do you do now? I told us that a single PV, all right, which is a single 610 watts, has around 50 volts, all right, VOC. Now, the 120 amps charge controller can handle up to 195 volts, all right. What that tells you is that you can actually connect three panels together in series, all right. You can connect three panels together in series, and that will give you 150 volts. All right, because if you add another one, it's going to be 200, which is going to be more than 195 volts. All right. So now, if you connect three panels together in series, it means that you have increased the maximum voltage. Just connected all the panels together. We assume that we are going to connect the panels together in parallel. Now you can connect three panels together in series. All right. So that if you have a total of 600 watt panel and the voltage after you have connected it in series is going to be what? 150. If you divide 6,500, 800 by 150, all right, 6,800 divided by 150, that gives you 45 amps. Which means that if your voltage is now 150 volts, you can actually buy a 45 amps charge controller. All right. But of course, you know that you're also going to increase this by 20% anyways. All right. So let's increase it by 20% times 1.2. So that's around 54.4. All right. And it's going to be approximately 60 amps charge controller. All right. Look at how cool that is. So let me explain this that I just did now. Let me explain, this that I just did now. So now remember we have 10 panels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now we have 10 panels. All right. And we said that if we connect three together in series, all right, we connect this to this, connect this to this, connect this to this. All right. Also connect this to this, and then this to this. All right. Um, what did I just do? 1, 2, 3, 1, 2, 3. Oh, sorry. Oh, I made a mistake. It's 3, 3. I went to connect 4, 4. Okay. So connect this to this. All right. And then um, connect this to this. All right. So you're going to be left with one panel. All right. Because by the time you connect three together, you're going to be left with one panel. But you can't throw away the one panel. It means that you have to buy two more panels in order for you to connect these also in series. All right. Which is cool compared to buying is either you remove one panel or you buy two more panels. All right, it makes sense, right? Because instead of buying five extra charge controller, at least you can just buy two more panels or remove one panel so that you just connect three together. So now for me, if I'm looking at money, if I see that the client does not have money, that kind of stuff, I'll just decide to remove this one. All right, because remember, we actually expecting 65% efficiency from the panel. All right, which most of the time is going to be more than 65%, right? But we used to calculate the worst. Shey you get? So the nine panels are still going to deliver. All right, how many panels is it? 11, or I think it's 11 now. No, it was 11. Wait, let me
Yeah.
divide it again. 6,800 divided by 610. So that's yeah, it's 11. So we're actually supposed to have 11 panels. All right, so let's put back our 11 panels. It's 11. So this is 10, 11. So it just makes sense to add one more panel in this case, right? Because we already have 11 panels. So let's just add one more panel to it, and so that we can connect this one also in what? In series. All right, together with this. Okay, so with this connection now, we only have to buy a 60 amps, charge controller in order for us to connect this. All right. So the first what's it called? The first one I gave us, right, is when you have a very small system, and yeah, that works, all right. But when you have a large system, you have to find alternative ways to do it. All right, you have to connect. You have to look at the charge controller. First question is, how much voltage can this charge controller handle? All right, so this charge controller can handle up to 195 volts. All right, which means I can connect three panels together to give me 150 volts. I'm still safe. All right, and then so I can if I divide 150 by 6,800, it's going to mean 45 amps, which means I could get 60 amps charge control and so on. All right. So now another way to do this, I'm going to put all the three ways together. It's going to make sense, right? Another way to do this, all right, is after you have checked out the let me remove all of this first. All right. So another way to do this is that after you have checked out the panel. So the 610 panel, each of them has 50 volts. All right, each of the panel is rated 50 volts, about 14 amps. All right, about 14 amps. Now, now we know that if you connect panels in series, all right, one, two, three, four, five, six. All right, one, two, three, four, five, six. All right. So if you connect these panels in series, remember connecting in parallel in series means you are going to connect unlike terminals. This is plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. All right. So you're connecting positive, negative to positive, negative to positive, negative to positive, negative to positive, negative. Oh, sorry, we're supposed to connect it in. Remind me, 3 3. All right. So, all right. So this becomes your output for this one. And this is your output for this one. All right. Again, plus to minus, plus to minus, plus to minus. So this becomes the output for this one. This becomes the output for this one. All right. So now, remember I told us that when you connect panels or battery in series, their voltage increase. What that means is that this panel 1, panel 2, panel 3, all right, both of them will have what? 150 volts. I mean, the three of them will have 150 volts as the output. Another panel 1, panel 2, panel 3, they will have an output of what? 150 volts. All right. Remember, each of the panels are rated what? 50 volts, 14 amps. All right. But we're connecting in series. It means that after we connect in series, the voltage will increase, but the current what? Will stay the same, which means the current will remain what? 14 amps. I'm trying to make us understand this thing so that we're not just cramming it. You understand? You're understanding what you're doing. Okay. So each of the panel is 50 volts, 14 amps. Right. By the time you connect in series, all right, the voltage will increase, the current will stay the same. All right. So we have 150 volts, 14 amps here. All right. Also, you have 450 volts, 14 amps. This one also 150 volts, 14 amps. All right. So you have four pieces of 150 volts, 14 amps panel. All right. So the next thing is you have to connect these four set of panels together, and you can only connect them together in parallel, not series again. Because if you connect them in series, it's going to be up to 300 volts. Remember, your charge controller cannot handle up to what? 300 volts. The maximum you can get is what? 120. All right. So if we now connect this string, let's say string 1, this is string 1, all right, S1, S2, all right, S3, and S4. String 1, string 2, string 3, string 4, all right. If you connect these four strings together in parallel, their voltages will stay the same, but the current will increase. So you have to connect positive to positive in order to connect in parallel negative to negative. Wait, let me use another um, all right, so positive to positive, all right, negative to negative, all right. This one also positive to positive, all right, negative to negative, all right. So, can I do this very, very well? I don't want to. So, negative to negative here, all right, positive to positive, negative to negative. That's how to connect in parallel. After then, you now connect these two also. This is positive, all right? Connect this positive to this positive. Let me, and then this negative, all right? So you have one output here, one output here. Please let me know if that connection is clear, or maybe I'll redo it again so we see. I was supposed to leave enough space though. So we connected S1 and S3 together in parallel. All right, we connected the positive to the positive here, negative to the negative here. All right, so this will give us these two strings in total will give us 150 volts, 28 amps. All right. Also, this one will give us 150 volts, 28 amps. All right. Now we can also connect these two. All right. So let's call this one. Let's call this connection one. All right. These two that we have just connected. This one we're calling it connection one, and then this one also we're calling it connection two. So if you connect C1 and C2 together in parallel, it means that you have to connect the positive here. All right. We have to connect the positive here, find the positive here, connect it together, and also the negative here, all right, connect it to this one, all right. So this means that you have actually connected together in parallel. Another way you could have connected this in parallel is simply connect all the positives, all right, connect all the positives, All right, connect all the positives. All right, so this is positive, this is positive, this is also what? Positive. So find a way to connect all these positives together. All right, all these positives, connect them together. All right, also connect all the negatives. No, all the negatives. All right, connect all the negatives, connect them to one point. All right, that way you would have connected it in parallel. So if you connect it in parallel, remember only the current will add up. What that means is that each of the string has what? 14 amps. All right, each of the string has 14 amps. Each of the string has 14 amps. So by the time you do 14 times 4, all right, what would that give us? 14 times 4. That is 56 amps in total. All right, so by the time you connect this whole thing in parallel, you are going to have what? 150 volts, 56 amps. All right. So if you want to go buy a charge controller now, for instance, you just need to go buy a charge controller that can handle 150 volts. All right. 56 amps. So for me, I'll simply just go and buy I can go buy um, I can go buy an 80 amps charge controller. All right, because if you multiply this by 1.2, because you have to create that room for it also. All right, times 1.2. That's around 67 points, 2 amps. So I'll just buy an 80 amps charge controller. All right. So an 80 amps charge controller should be able to handle up to 150 volts. I think it handles up to about 165 or so. All right. And if you cannot handle 150 volts, just buy 100 amps. All right. 100 amps can handle 150 volts, and you are good. All right. Please let me know. Let me know if everything I've explained is clear. Confirm is clear, please. Okay. All right. I've pretty much tried today. I think we might want to round it off on Saturday, not Friday again, because there's something else I remember that I've not talked about. Okay. There's something else I remember that I've not talked about. There's something else. Okay. 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 Thank you, guys. Yeah. Well, we'll see how tomorrow goes. All right. We'll see how tomorrow goes. So hopefully, there's nothing so much left. There's nothing really much left. There's nothing really much left. I mean, apart from the cable sizing, how to select fuses and breakers, all those kind of stuff, and then protection also, right? All right, we'll see how tomorrow goes. Okay, thank you guys. If you don't have any question, we can call it a night from here. Okay. All right. Bye. Have a good night, everybody. We'll see you tomorrow.